So PC1 wants to send some data to PC2, but how does that work underneath the hood? Well, let me remind you first that you cannot send raw data through an Ethernet cable because the cable can only carry or transmit zeros and ones or bits as we know it. And so this data that we have right over here must be wrapped repeatedly until it becomes a series of bits, which is what's being sent through the Ethernet cable. And so that is when the term encapsulation comes into play. So think of encapsulation as wrapping the same gift over and over and over again. So that is, the gift has layers of wrappers inside of it. So basically that's what we're doing with the data, is that we're going to encapsulate the data with protocol information. And so without further ado, I'll show you how the encapsulation process works, and I'll also show you how PC2 will eventually open PC1's gift. So that is, PC2 will eventually decapsulate the bits it had received from PC1 to reveal the data. And so we'll start by encapsulating the data into a segment. And so how we can go about doing that is that we'll simply attach a TCP header right next to our data. And so the TCP header has stuff like the port numbers, the sequence numbers, etc., etc. And so by attaching a TCP header right next to our data, we have what's called a segment. So again, the segment has the TCP header and the data. Now that we have encapsulated our data once, we must do it 3 more times. And so we're going to encapsulate this segment into a packet. And we'll do that by attaching an IP header right next to our segment. So the IP header has stuff like the source and the destination IP addresses, plus a lot of other important things too. And so when you have an IP header and a segment together, you now have a packet. So again, the packet has the IP header and a segment. So we're halfway there. We'll continue by encapsulating this packet into a frame. We'll do that by attaching 2 things: an Ethernet header, which has the source and the destination MAC address, and an Ethernet trailer, which has some sort of integrity check algorithm. It basically makes sure that the frames are not being corrupted whatsoever. And so what you're looking at here is a frame. The frame has the packet, the Ethernet header, and the Ethernet trailer. And finally, this frame will be converted into bits, or zeros and ones. So these bits are in the form of electrical signals, are what's being sent through the Ethernet cable all the way to PC2. Now that PC2 has received something from PC1 to reveal the data, it has to decapsulate the bits 4 times. So that is, PC2 will open the gift 4 times to reveal the actual gift itself. So that is the data. And so PC2 will start by converting these bits back into frames. And if you forgot what a frame has, it has the packet, the header, and the trailer. PC2 will decapsulate for the 2nd time, converting this frame back into a packet. It will do that by detaching the Ethernet header and the trailer. Now we're left with a packet which has the IP header and the segment. We will now decapsulate this packet by taking away the IP header, leaving us with the segment which has the TCP header and the data. And then we'll decapsulate this segment by taking away the TCP header, and then we are now left with the data. And so PC2 has now finally fully opened the gift. So that is, PC2 has now fully decapsulated these bits to reveal the data. And so let's see what PC1 has to say to PC2. So PC1 said hi to PC2. Let's see what PC1 has something else to say with PC2.